Hey guys, Mr. Middleton here. Today we're going to talk about zero and negative exponents. At the end of this video, you should be able to simplify expressions containing zero and negative exponents. Alright, so what's an exponent? Well, let's simplify a few expressions to see. We have x plus x plus x plus x plus x. Okay, we're going to simplify that and write that as 5x. So multiplication is repeated addition. Okay? Let's simplify the second expression of x plus x plus, or sorry, not plus, x times x times x times x times x. This is x to the fifth power. Okay? Exponents are repeated multiplication. So, which number represents the base? If we look at this, we have 2 to the 8th. 2 to the 8th, the base is 2. Which number represents the exponent? 8. What is the power? Okay, 8's the power. You'll notice exponent power really used interchangeably. There we go, that's the word. Okay. It says use the following example to help you understand the big ideas from this lesson. So notice this pattern. In the first column, 3 to the 4th, 3 to the 3rd, 3 to the 2nd. You see that our exponent decreases 1 each time. Okay. In our last column, you'll notice that 81, 27, 9, 3. What's happening? Well, probably easier to see from these numbers down just because we're more used to these values. 27 divided by 3 is 9. 9 divided by 3 is 3. You'll see that in the last pattern, the last column, what's happening is being divided by 3 each time. Okay, fill in the blanks using that pattern. Okay, so 3 to the 0 power, if we just look at the first column, should be that. Last column divided by 3 is 1. Okay, again, this is decreasing by 1, so what's happening? Well, our number's getting divided again by 3. So I'm just going to leave it as a fraction because that's easier to see. 1/3. Okay, again, divided by 3. 1/9. Okay, so as we look at these exponents, I want you to notice though 3 to the first power is 3. 3 to the negative first power doesn't make the number negative, but what it does is take whatever 3 to the first power is and it moves it to the denominator. 3 to the negative second power does the same thing. It takes whatever 3 to the second power is and moves it to the denominator. Okay, so if I had 3 to the negative 4th, I would see that that would be 1 over 81, taking 3 to the 4th power and moving it to the denominator. Okay, and so that's our pattern. We see that negative exponents move that power to the denominator. Power that whole thing to the denominator. Okay. Alright, so also, big idea here. 3 to the 0 power is 1. We use this 3 to show our pattern, but no matter what number we use, if we used 5, if we use 2, if we use 176, when we look at this pattern, anything to the 0 power would go back into to 1. So that's our first big idea. For every number a to the 0 power is 1. So 15 to the 0 power, 1. 3,142 to the 0 power, 1. Negative 23 over 61 to the 0 power, 1. Notice that this is in parentheses, so zeros distribute to the whole number, but yeah, 1. Okay, so anything to the 0 power is 1. As I already talked about a little bit here, for every number a, an integer n, a to the negative n is 1 over a to the n. Okay, so trick to help you here, if there's a negative exponent, its base is not negative. Its base is not happy with where it's at in the fraction. Okay, so here, when we write our numbers out, we will not write a negative exponent. Okay, so if we were to see this 3 to the negative 1, we would write it as 1 over 3 to the 1. And so notice what we did, since every number is a fraction, is we moved this down to the denominator to make it a positive exponent. Okay, so 3 to the negative 2 we would write as 1 over 3 squared, which again is 1 over 9. Okay, so got some practice problems to do here so we can see that in action. So it says simplify each expression. You should have no negative exponents in your answer. So we have x to the negative fifth. Have a negative exponent. Remember, we shouldn't have those. And so we're going to move that to the denominator. And so we have 1 over x to the fifth. For number 2, again, we have a negative exponent, but now it's in the denominator. So we'll move it to the numerator, because again, it's not happy with where it's at. We can move it up. That gives us x to the 9. Again, moving it makes it happy. Number 3, we have 7, x to the negative third, y to the fourth. As we look at this problem, there's only one thing here that's not all the way simplified. This negative exponent, we can't have it. So we have to move it to make it happy. And so we move that to the denominator. Notice that this is going to be connected with its base. Negative 3 is not by itself. Okay, it's connected with this base. So as I move negative 3, if you think about it as a kid holding the balloon, if I move the balloon, I have to move the kid with it. Okay, and so we have 7 y to the fourth. Nothing was wrong with either of these. Okay, so they get to stay where they're at, over x to the third. And now we have all positive exponents there. Alright, number 4. We have 5 to the negative second. We have this negative exponent. Not good, so we have to move it so that it becomes positive. Again, it's connected to its base. It doesn't move by itself. Okay, so we have 1 over 5 to the second power. Now, previously we had variables, so like x to the fifth, we couldn't do anything with that. 5 to the second power, or 5 squared, we know what that is. So we should simplify that and write it as 1 over 25. Okay, number 5, we have negative 22.4 to the 0 power. Anything to the 0 power is 1. Number 6, notice that there is a difference between 5 and 6. In 5, negative 22.4 was included in the parentheses, and in 6, the negative was outside of the parentheses. Okay, so what we'll actually be doing is 22.4 to the 0 power. We'll do that first because our order of operations tells us to do exponents, parentheses, simplified, then exponents, so that will be 1, and then multiplication. This is a negative 1 out here multiplying, so we have 1 times negative 1, which ends up giving us negative 1. Okay, number 7. Notice here that we have negative exponent in the numerator, negative exponent in the denominator. They need to move. And remember that they're connected to their bases. So now we have b to the fourth in the numerator, a to the sixth in the denominator. Okay. Number 8, negative 2 to the negative third. We want to move that to the denominator. So we have 1 over negative 2 to the third. And we can simplify this, so we will. Negative 2 times negative 2 is 4, times negative 2 is negative 8. Okay. Number 9, we'll do the same thing, move it to the denominator, negative 2 to the third. In this case, still going to be 1 over negative 8. So negative 2 times negative 2 is 4, times negative 2 is 8, or negative 8. Again, not a situation where I would recommend that you find a hard, fast rule to stick to. Okay, exponents means repeated multiplication, so repeat the multiplication. Negative 2 times negative 2 times negative 2. Simplest and most understanding way to go through it. Number 10, we have 4x to the negative second over y to the 7th. Okay, so as we look at our problem, we say, okay, what's wrong with this problem? Well, we have a negative exponent. It needs to be addressed, so we move it. Okay, the exponent is connected to x. 4 is okay where it's at. It doesn't need to move. We need to move the x to the denominator. Y to the 7th is happy where it's at. We won't move it. Keep it in the denominator. Okay, number 11. If we look, we have negative exponents. It needs to move. It needs to move. Okay. We also have a 0. Okay. Remember, anything to the 0 power is just 1. And with multiplication, it's almost like it disappears. We have 1 times m to the 4th. That would just be m to the 4th. So we kind of get rid of that. Okay, so get rid of that understanding it's 1 times n to the 4th. So, up top, notice that we moved everything that was up top. So now there's just 1 left. Again, it's 1 times this times this. We just don't write the 1. Okay, unless there's nothing else there. So, in our denominator now we have 3 squared, which we move down, so it would be positive, m to the 4th, and n to the 5th. Okay, and when I deal with a bunch of numbers or variables, I usually try to think of it in alphabetical order just so I can know that I've addressed everything. And that's how they're typically written. Your answers are typically written in alphabetical order. Alright, again, I would recommend that you look through your problem, see, did I address everything in this problem? Is everything simplified? Here we have 3 squared. That is a operation that we can do. That's 9. So 1 over 9 times m to the 4th times n to the 5th. That's our final answer. Alright, so gone through 11 problems here. I know I'm leaving this most difficult one for you to do, but I want you to think through those rules and try it for number 12. Okay, try that out, bring it to class, complete it. Alright, so let's look at evaluating expressions. Okay, evaluating expressions, just evaluate, remember, just means to plug in and simplify. Okay, mathematically evaluating means plug in a value and simplify. My recommendation for you is to simplify the expression before you plug in numbers. Okay, now, I say this, and I want to make sure I say this, just because you have a calculator does not mean that you will get the right answer for these, especially on tests and quizzes. Okay, I will ask you to write this as a fraction, or I'll ask you to write it as a decimal, either way, but you should be able to do both. With the negative exponents, it's harder for you to input it accurately into your calculator as it is. So, again, my recommendation is that you simplify the expression, making sure there are no negative exponents, no zero exponents. Then you plug in your value and go through it with understanding rather than trying to luck out of it by typing it into your calculator. So for this problem, We have 4m to the negative third, n to the negative second. So I need to move these things. Okay, when I move them, I now have 4n squared over m to the third. Okay, so I got that down. Now that I have that, what I'm going to do is I'm going to plug in my values. So I have 3 squared, because n is 3, times negative 2 cubed. And then just make sure you go through this using your order of operations. Order of operations will tell you to do exponents. So 4 times 9 over negative 8. And then simplify. So 36, negative 8, simplify, that gives us 9 over negative 2. And here's our answer. 9 over negative 2. Okay. Alright. Last problem here says evaluate 5 to the a power times b to the negative third. I'm going to plug in the values that they gave us. They told us that a was 0. I'm going to change this so I have over b to the third. Okay, and so I have 5 to the 0, which is 1. B is negative 3 to the third, which gives me negative 27. 1 over negative 27 is our final answer. Alright, so there you have it. We've looked at 0 exponents and negative exponents, how to simplify those expressions, and some of those rules. See ya.